So welcome to the pre-recording of lecture 4 of MCS 260, which is the second part of the second session of our 8-week summer course. Today is an important lecture because after today we will be able to write a complete interactive Python script. And with that, we will already know enough to do our first computer project. So the lecture of today is a milestone. What you therefore need to learn still is how to work with variables, how an assignment works, and how Python sees variables referring to objects. Every object in Python, so an object will be later in this course made very precise, but an object is something that can be a number, can be a string, but with the first part of this session, we've seen that internally in this computer, everything is just a sequence of zeros and ones. For us as programmers, it's very important to know what is the type of every variable. Even if it's not yet completely obvious, it's very important for the outcome of our computations. So that's important, and that can be already be quite problematic when you misinterpret the input of the user. So if your beginning data, your initial data are wrong, then what follows will also be wrong. Okay, let's look into assignment operator. So when we are using variables to hold values of certain objects. When you type x equals r, and actually the equals is not the equal sign, I will get to that later. But what actually happens is that what is at the right side is evaluated. So the result of that evaluation will be preceded by the parsing of the right-hand side into an integer. The address needs to be computed. The address is in the language of the first part of the session. The address is where the value will be stored in main memory, or will be stored in a register first before it is placed into memory. Then the right-hand side, the result of the evaluation, will be placed into a data register. And then in the last step, when it is in a data register, it can be placed in the proper spot in main memory, in the random access memory. So this is very roughly the 5 stages as we see this still in a high level environment. So if you would look into the actual machine code, there would still be many intermediate steps, but this is in a way what happens, how an assignment works. What is the machine view, and actually what is also the view for the Python programmer? The Python programmer, so the bottom line of the slide, what you need to know is that we have x as a name, and that refers to the object. The object encapsulates the value of the variable it refers to. Here the value is the integer 3. So the encapsulation also incorporates the type information. So that's why the square box and the round circle kind of Python stores a lot more than just the 2 bits that would be strictly necessary for the integer 3. Um, we can actually ask in Python for the address. So Python provides also somehow an access to the machine view. So in the middle of this slide, we see the actual value of the reference, which is actually a number, which is an address of the variable. So what is stored is not only the name, but also the physical address or the address of the physical location in main memory. Um, most Python installations are based on the programming language C, and they allow you to dereference, giving the idea you can ID the output of the idea you can get to a value. I need to look up how this happens. As a Python program, you will never need this, but if you have the address, you can actually also get to the value. That's the lower level of seeing things. Okay, Python is a memory managed language. So when you are assigning to a variable, there is also memory that is allocated. So there is space that is somehow freed in the random access memory to hold the value of the variable. So in languages which have which force the programmer to explicitly um, go through the memory allocation steps, there is a lot more that needs to be done before an assignment can often happen. Here we have automatic allocation, and we also have automatic deallocation. It's called garbage collection. So you have to know that these terms exist. So memory allocation, memory deallocation, garbage collection. But as a Python programmer at this level, we do not need to worry too much about this, except that we may sometimes do this explicitly. So what actually is happening when we do an assignment, uh, both of the variables x and y, they refer to the same object, to the same value. But you can see that if you delete x, then you can no longer refer to 3 via x, but you can still refer to 3 via y. So we have the two locations. You have the actual object 3 that is saved, and then you also have the name of the variable that also occupies, which is, if you like, an other word for the memory address. So you can explicitly delete it, but if you delete the reference, then if there is still another variable referencing to the same object, the object will still be there. So the memory management will actually only erase the object if all references to that object have disappeared. So here is the visualization. So we did two statements, and by the way, have executed these statements in the interactive Python shell at the PowerShell or at the command prompt window or at the terminal. So the three larger than symbols refer to the prompt of the Python shell. This would be a code cell in a Jupyter notebook. So here you see what has happened. We have the two references to the same object. one reference disappears as a consequence of the deletion of the name of the variable. Okay, let's now go into the second part. My timing is perfect now, 10 minutes in. So Python is dynamically typed. When you compute with values, Python infers the type of the object you're computing with. This is very convenient, but it doesn't mean that you, as a programmer, should ignore that there is typing happening. Because the kind of arithmetics depends on the kind of type that you work with. So there is dynamic typing opposed to static typing. I mentioned the language C, and other languages will require you, and that's mainly typical for compiled languages, they will require that you as a programmer declare the type of, um, of a variable. In Python, we can query, so there is the type of a name. So name is the name of a variable. We can query the type, but we can also do a type cast. We can convert from a type, from say an integer type to a floating point type, or from a floating point type we can round or we can truncate that floating point number into an integer. Notice that so every variable, every object has a string representation. So we can always convert any object into a string. And remember that we can do the opposite also via the eval function. So we can evaluate a string into a numerical type. Again, emphasizing that you can add two numbers, 1 plus 2 will equal 3. If you put right quotes around 1 and 2 and then do the addition, this will work as well, but that will produce the string with content the letters 1 and 2, or the symbols 1 and 2. It will look like 12. We will distinguish between elementary types and composite types. When we write more interesting programs, more um, complicated programs, we will use composite data types. For today, we will focus on the 4 elementary types: the integers, the floats, the characters, and the booleans. Actually, a character doesn't really exist in Python. The character is undistinguishable from a string of length 3. Okay, in the first part of the session, or in lecture 3, we said that there is the integer arithmetic and the floating point arithmetic. And actually, the integer arithmetic is arbitrary precision arithmetic. But still, we need to distinguish between the machine integers and the long integers, and the arbitrary precision integers. And in particular, the 32-bit and the 64 bits. So the 32-bit integers, the machine integers, have 31 bits for the numbers, and then there is a sign bit. So you can represent about 2 billion numbers. So remember, 2 to the power 10 is about 1000, 2 to the power 20 is a million, 2 to the power 30 is a billion. So we have about a billion numbers. Looks a lot, but 32 bits is no longer sufficient as the addressing space for modern random access memories, which often are expressed in multiples of, so you probably need 16 gigabytes on a regular computer. If you have made the first exercise of the previous lecture, then you know how much internal memory your computer holds. Here you can compute the largest and the smallest machine integers for 32 bits and for 64 bits. This gives you somehow a range. Um, why is this important again? If you would prototype your program in Python and go to a language such as C or other languages that for which the default type are machine integers, then you have to be aware that overflow or underflow may occur. Um, Okay, the other elementary type are the booleans. We will say more about booleans and computing with booleans when we get to conditional expressions in our control structures. It's important here, I had the assignments x equals 3, and that's the wrong saying. So x equals sine 3 is the operation for the assignment, and by now we actually know that many instructions and many things are happening when we write that statement. After the assignment, we can write x double equal 3, and that should give true. X double equal 4 is false. So we can compute with those logical expressions. In some sense, the true and the false, you can represent them, you can consider them as the string representations for the bits. False is 0, true is 1. And we will later see how to compute with truth tables to enumerate all possible outcomes of logical expressions. All right, why is this also relevant for a programmer? Well, as a programmer, you transform information. Remember again our first definition of computer science. So you take user input and you translate into output. So when you prompt, everything that the user types in is actually returned to you as a string. And then you have to parse it, so you have to translate it into what you want to compute with. So there are two ways to do it. Actually, there are many ways to do it. Here, when you compute for a number, you use the word input. So input is the name of a function which takes on input a string. That's the prompt. That's the I mean, you can omit it, but that will make your programs not so user friendly, or you omit it when your program is in dialogue with another program for which the prompt is not needed. But it's strongly encouraged to work with a message that asks kindly the user to give a number. Now, give a number, what that number will be. You can leave it up in the air as a programmer. You can say I'm assigning it to S, and S is any string. And whenever necessary, if I want to use this as an integer or as a float, I will convert it as an integer or as a float. You can do the conversion immediately. Now, why is that important? When the user types in something that is not a number, that cannot be translated into a number, an error message will appear. And we will later see how you can, as a programmer, can make your programs more robust, and you can work with exception handlers. So you can There's a lot of flexibility there. But for now, the programs that we will develop will actually assume that the user is well behaved, will not type in anything that is not a number when we ask for it. All right. You can also apply Python's dynamic typing. So there is the eval where you call the evaluation of the string. There is also the literal eval. So with the literal eval, you invoke part of the interpreter. So the interpreter, which you the literal underscore eval, you import from the abstract syntax tree module. So in a way, if the user types in 3.3 or 3.4, you can leave it up. So you can, in your program, you can test on whether what is the type, and then you can do the proper arithmetic. Um, so if the user types in 3, it will become an integer. If the user types in 3.4, it will be parsed into a float. Okay, so the purpose of these lectures is that you can start on the exercises. So the first exercise asks you to explain why you see 1.1 that there is this dangling 0.2 there. The short answer is that 0.1 cannot be represented exactly in binary. So I mentioned the module decimal in the previous lecture. You can redo this with the decimal module. But the answer is that we work with machine integers, and there is a representation error with 0.1. You have to explain this answer in the way the plus is executed. So the input, the two operands, are interpreted by Python as floats, and therefore they are represented internally as floats. So there is a representation error with the representation of 0.1. And therefore you observe also that representation error in the output. So it's reflecting the theme where of the parsing of the input. So if you make an error on the input, then your output will also be wrong or not exact. Um, the um, the formatting of the string here, so we want to see 0.5 with 40 decimal places in the scientific format. Um, Explain why that differs for 1/2 and 1/10. It's the same question essentially, the same exercise. If you can answer one, then you can answer two. 1/2 can be represented correctly in binary. So that is why it is exact. Um, um, Exercises 3 and 4, 5, you should be able to do after the um, second part of the lecture. So we will develop interactive programs where, for example, program 3, the user is prompted for hours, minutes, and seconds, and then it is converted into the number of seconds. So here we work with a number system that is using 60 as a base. So I should actually have mentioned this when we worked with the decimal and the binary. So we are still working with a 60 base when it comes to working with minutes and seconds. So formulas are important examples of algorithms. Algorithms that can be tested and developed very uh, straightforwardly. But what will happen in the second half of this lecture is where I will slowly traverse through the development of a formula. Okay, I had the plan to develop the program in an interactive way. I will do so during the actual lecture. So in some sense, doing this pre-recording gives me some background. So this is actually what I want to show, but I'm sure that in an actual lecture I will make too many mistakes, but I will indicate on I have something to fall back to. Um, so I have a fully prepared Jupyter notebook. And perhaps I should indicate a little bit if you load a Jupyter notebook. So if you load a Jupyter notebook in, so I should probably show the complete environment now. You have the options kernel and run. So if you download a Jupyter notebook, or if you click on the um, notebook, and so you have the file browser here. So when you load in a notebook into the Jupyter environment, you would think that the variables say day equals 14, but this is only the case if you have executed the statement. So often it's good practice to run all cells when you load in a notebook, except that for this particular notebook, you shouldn't be doing this because there are explicit input statements. So that is the warning here. You can always restart a kernel and clear all outputs. And this is something that I also do when I prepare a notebook that I will post. So often there is a lot of trial and error, and there are errors. The order of execution. There seem to be missing code cells. To make sure that all the numbers lie up neatly, I do the restart and clear all outputs. And then you can run one cell after the other. So in this sense, if you look at this Jupyter notebook, you can still run through this step by step and execute it. Okay, I will do this whenever necessary. Actually, I have already ran it, so everything should be working properly. So I gave the old school percent notation. This fits within the computational aspect. So you have a format string and you have a percent operator. So the percent operator is used in the format strings. It's actually not the recommended and one could say the modern way to work with formatting. Here you see, so this fits also within the scope, within the story of variables. So if you want to make a date string, you can just type in date equals and then quotes open 14 June 2023. But that will only work, this will only be valid for that the particular date that you had in mind. what you can do with a format string or an F string, you can make your string depending on the variables, the day, the month, and the year. So if I change the value for the variable day, then running the date string, I don't have to change anything in the date string, but that will produce a new a new string with the proper value, the adjusted value for the day. So the F string formats the integer 14, the string, the month, June, and the year into one complete string. This is the proper way, the recommended way how to make output strings in the current version of Python, already since Python 3.6. So we are using the curly braces to enclose the name of the variable. Note that for this f string to be valid, the day, month, and year must exist when you execute the f string. Okay, so integers are formatted then in a very natural way, just as you place strings in a string. For numbers, we have the choice. For floating point numbers, we have the choice between the fixed format and the scientific format. So when we typeset the number 123.45678, if we want to typeset this with 4 decimals, accuracy, then we can choose in the fixed format. So 4 decimals, 1, 2, 3, and you would think 4, but no, it rounds properly. So the information stored in a 4 precision string of 4 decimal places. Accuracy is 123.5 in the fixed format. So here you need to know the size of the number. So you actually need to know if you want 4 decimals of accuracy in the result in the display, you need to know the size of the number. In the scientific format, if you want 4 decimals in total of the accuracy, you provide the 0.3. And then you actually read the number from right to left. You see the magnitude in the exponent. So you see that this is a number in the hundreds. Okay, so now we arrived at the development of our first complete interactive program, starting from a formula, so a formula to compute the balance of an investment, and also we will compute the yield. So let's start with a numerical example. We have $1,000. The interest rate is 3.12%. And what will be the balance of this investment after 1 year? We multiply the 1,000 times 1 plus the interest rate. And that gives us the value $1,031.20. So you see that the formatting and the rounding is actually necessary for this type of application. It's important already that we are able to distinguish the main actors in this computation. So we have the principal, the $1,000. We want to do this more general computation. So this will be a variable called P for the principal. We have an interest rate, 3.12. And then so these are the two inputs. And then we have the output, the balance. So depending on how we think about when we think about formulas, there is the inclination to work with letters. Often, when you think about code and pseudocode, you might be much more inclined to use explicit, longer letters. Bugs often occur when you use the same variable for different objects. Okay, let's redo the computation, but now with the variables. So we have PRB. So we assign 1000 to the principal. We have the interest rate, and then we have the formula. Uh, if you want to do this only for those numbers, but we also want to do this for a number of years. So we have an additional variable, and remember that the exponentiation is the star star. So this gives us the um, first formula to compute the balance of an investment of a principal at an investment rate R for a fixed number of years. So that's the balance, so that's the first output. And we have the yield, which we will denote as Y. Yield is the difference of the ending balance, B, minus the beginning balance, the principal. So in 5 years at from $1,000, it has given us $166.04. So in a way, you could see this notebook somehow as a spreadsheet. And doing computations with this. So if you are interested in doing just computations, then this is great. And this is a pre-processing step to fully understand the input-output statement, and also here essentially understand the formulas that are involved. So we have two formulas. So in such a way, you can already see how algorithms are more general than formulas. Okay, let us state the input-output specification. We have three inputs, a principal, an interest rate, and a number of years. We have two outputs, the ending balance and the yield of the investment. The need for formatting is already obvious, so you don't want to see 19999. So you want to round this. The same with the yield. So to be very explicit, what the program it computes an entire sentence, um, confirming the output. So what is the investment amount, the interest rate, and the number of years, and then also inserting in that sentence the computed numbers. So, and this actually specifies what the program should do. Notice that we have dollar amounts, we have percentage symbols, we do have integers, so the number of years. And then we have the floats. So the principle, even if we type in a very nice round number, 1000, it should be interpreted as a floating point number. The same with the interest rate. So if and that's actually even more important, if the user types in a nice round number such as 4 for the interest rate, then in our computations we must interpret this as a floating point number. All right, every program in some sense is different, but every program in some sense also the same. It interprets the input, it takes input, it does a computation, and then it defines the output, and then it renders the output. The output rendering could be just printing to screen, as we will be doing, But we will also see that you may want to compute this in an HTML form, in an interactive web environment. So the prompting of the input would be different, and the defining and the rendering of the output would also be different. But the central part, the computational part, would remain the same. Okay, prompting for input. So, and here is where we deviate from the uh, normal interactive nature of a Jupyter notebook. Normally, you would never in a Jupyter notebook write statements like this because they are very inconvenient. So let me actually execute it to illustrate what struggles will be. If you run this, and it will run, so it gives me a problem. Um, so the problem is most likely that I have executed already this, and I should probably now relaunch the kernel. So let me indicate how I can do this. So you see how difficult, how I will restart the kernel. So let me restart the kernel. It warns all variables will be lost. And also let me remove all the output, clear all the outputs. So this is a clean slate. So I start from the beginning with my session. So now I can run this. So the statement is perfectly fine. So I have now an input box that appears. I type in a value, 1000, a nice round number. You see the star that is still hanging. And now I press enter, not shift enter, but just enter. So, and I see the number. And this was the first statement that I executed in this Jupyter notebook now. So normally in a Jupyter notebook you would write principal equals 1000, you would assign this. But this is because we develop this program. So the interest rate is 3.12. So I'm simulating, so I have to press enter. So I'm simulating how the user would execute this program. So the number of years is 5 in my running example. Pressing enter in the box and then confirming. So this is the initial stage of this algorithm, of this program. It's a little bit pedantic, but I'm now sure that these three statements that they work. I can copy and paste them or type them over into a .py file. Also, I have the values for principal, rate, and years, and I can start computing with them. So here you see the code cell that computes with it. So if I execute it, shift enter, I have the balance. If I do again shift balance, oops, shift enter, then oops, another error occurs. But you see, I prepared this, and I should actually also have mentioned this. Variables are names, and it's actually not good if you introduce something to say what you can't do. Well, you cannot pick any name that Python already knows. So it would not be good to start using the word if, for example. If is the name of a control statement. So you cannot name a variable if. You cannot name a variable yield because this is already used by Python. So it is a syntax error. This is where a command fails, and I make it succeed by choosing another word, capitalize it, so it still can still call it yield. Okay, so let me continue with the next step. So the third stage of the program, computing the sentence. So I will build the sentence step by step with the F strings. So I have my dollar amount that I put in there. So I'm investing the principal, and actually it's not entirely correct. I should format this as fixed floating point number. So it's not an integer, it's an integer in the example. So actually my example is actually, so you see this is a very simple program, but there are so many things that can go wrong. So actually also the format string should actually be corrected. So I stand again corrected. So let me format the correct format string. So this is what it should be. Okay, I'm investing this principle and now it should go smooth sailing. So let me do Shift Enter. Note that you might be running out of inspiration for good names. So I have the segment of the string that has the investment rate. So don't call this rate because then you lose the original rate. So there is the rate, which is the number 3.12, and then there is the at rate that holds the string and the result. The same for the years. So you see years in the name 4 years, you see years in the name of the variables, and you see years in the output string. Um, they're all different. Okay, now I have the segments of the input and the output. I kind of violating my recommendation to assign to input. Input is also the name of the command input, but Python does not protest this. And that it was the error that I made. Choosing input as the name of an variable leads to important consequences. So input is not good name here. Let us call it our input, because I will lose my access to the input command. So this is another mistake, and I was actually fooled by that as well. The fact that the string was not executable um, was the correct syntax error because the input was overwritten. All right, and then I have my full sentence that is computed. All right, I hope that this is not too confusing. So now I still need to show how you get to the program. So I will launch a terminal window. So you can also now, so I have already put everything into a Python script. So here is the Python script. So you could work differently. So you could edit the .py file and gradually put the statements in there. So this is a program designed to run at the command prompt. So, and let me therefore also do this. So my principal is 1000. My interest rate is 3.12, and now as a user I'm at my best behavior. I don't type anything wrong, and you see what comes out is the formatting, the output sentence, but now split it in the input data, confirming the input data and the output. Okay, so I can explain this in about 15 minutes. So you can see that even if I have prepared this in a pre-recording, there are many things that will go wrong and do go wrong. So when you write your first programs, Please do not be discouraged. Do not give up when Python is not collaborating with you, but persist, and every statement that executes correctly, treat it as a victory. So I hope that this lecture was informative, and I hope that you realize that we have accomplished quite a lot in this lecture.